So in the last class, we have started the Townsend's current growth equation. This is a very important topic. So till now, whatever the basics we are seeing are for understanding this topic only. See, I hope my voice is audible. If not, you can ask me. So Townsend's current growth equation. This is our experimental setup. So as you know, so this is a cathode negatively charged plate, and this is anode positively charged plate. So these two plates are supplied power using a high voltage adjustable voltage source, and we have got ammeter and voltmeter, ammeter for measurement of current. So any discharge measured by means of current, and this is a current limiting resistor. So if any spark happens, that spark is nothing but a short circuit. So that current can be measured using ammeter, and so to limit the high current because of short circuit, we will arrange an current limiting resistor. So these two plates, between these two plates there is a gap. So that gap is filled with some gas. So whichever the gas we want to test, that gas will be filled between these two plates. So to initialize the process, we'll use some ultraviolet light. So we'll apply some ultraviolet light. So they will create initial number of electrons. So that current is I0. So this is the case. So we'll look at this diagram. In this diagram, we can get few more points. If you see again, we have got anode and cathode. Okay, so this is cathode and anode. So here N0 is the initial number of electrons. Here N0 is the initial number of electrons. So d is the distance between the two plates. Here small d is the distance between the two plates, and so here small x is the distance. So we are trying to analyze by this way. Here at a distance small x, number of electrons are nx. So initially there are n0 number of electrons. So as they move, so initially there are n0 number of electrons. As they move, because of the ionizing collisions, so those electrons will increase to nx, right? So because of collision, because of ionization, or ionization because of collisions, those electrons will increase from n0 to nx. So initially if there are some 100 electrons here, so after some collisions they may become 1000 or 10,000 here. Okay, so the number of electrons will increase to nx. So again we'll take a small distance dx for our analysis. So dx is the differential distance that we'll take for our analysis. Okay, so here small d is the distance between two plates. So this is the total distance between two plates, and small x is the distance from this plate to this point. So at a distance x, the number of electrons are nx. So at a distance x, the number of electrons are nx. Okay, and dx is a small distance. So differential distance, this is for our analysis purpose. Okay, so this is the diagram we will take for our analysis purpose. So if you see the initial points, so these are the points that are there. So let us assume So let us assume that n naught electrons are emitted from the cathode. So initially there are n naught number of electrons. So initially there are n naught number of electrons. So when one electron collides with neutral atom, so see the second point, when one electron collides with a neutral particle, a positive ion and an electron are formed. So this is called as ionizing collision, that you know. So when an electron collides with a neutral particle, so what happens is a positive ion and an electron are formed. So this is what is collision, right? So when an electron collides with an neutral atom, so you will get an electron and an ion. So these are formed. So that is called as ionizing collision. And again we have one more new term to be discussed here. So here alpha. So here alpha be the average number of ionizing collisions. So here alpha be the average number of ionizing collisions. So here alpha be the average number of ionizing collisions. So we are defining here a new term called alpha. Let alpha be the average number of ionizing collisions made by electron per centimeter travel. So in the direction of field. So here we are defining alpha. Actually this is the definition of alpha. So here alpha is the average number of ionizing collisions made by electron per centimeter travel in the direction of field. So simply you can say alpha as the average number of ionizing collisions made by electron per centimeter travel. So there is a name for alpha. Alpha is called as the Townsend's first ionization coefficient. So alpha is called as the Townsend's first ionization coefficient. Okay, Townsend is a name actually. There is no space between these two words. So alpha depends on the gas pressure, that is P, and also potential by E by P. So it also depends on E by P. So that is one more parameter that can be considered. E is the potential, applied potential here. So alpha is called as what? Townsend's first ionization coefficient. So simply, how can you define alpha? So alpha is the average number of collisions made by electron per 1 centimeter travel. So alpha is the average number of collisions made by an electron per 1 centimeter travel. So that is the meaning. So you can see here alpha is the average number of ionizing collisions made by an electron per centimeter travel. Okay. So you can call it as average number of collisions made by an electron per centimeter travel. Moving on to the next slide. So at any distance x, so if you see here, at any distance x from the cathode, let the number of electrons be nx. So as we have seen in the diagram, in the second diagram, which is drawn using a pen. So at a distance x, the number of electrons be nx. Okay. So when these nx electrons travel a further distance of dx, so here dx is the differential distance. So when these nx electrons travel a further distance of dx, differential distance, they become, or they give rise to alpha nx dx. So if these nx electrons further travel a distance of dx, then they give rise to alpha nx dx. So here alpha is the Townsend's first ionization coefficient, and nx is the number of electrons at distance x. So dx is the differential distance. Okay. So this is your initial condition. At x is equal to 0 and x is equal to n naught. That we can see from the diagram. At x is equal to 0, that means we are at cathode. X is equal to 0 means we are at the cathode. That is, at cathode number of electrons is equal to n naught, right? So at cathode number of electrons are equal to n naught. At a distance x, they will be nx. If they travel distance d, they will become nd. So that is what the terminology is. So from this diagram you can understand. Okay. So if x is equal to 0, the number of electrons are n naught. So that we will use for initial condition, like we will use that at x is equal to 0, number of electrons are n naught. At, at a distance x, the number of electrons are nx. So if they travel a further distance of a small differential distance dx, so dx is this distance, very small distance dx, the number of electrons will be alpha nx dx. Okay. So we'll move on to next slide. So this will see the derivation part here. Okay, I think you are able to see the screen. So if there is any problem, please inform me. So if you see here, dnx is the increase in number of electrons. dnx is the differential increase in number of electrons. So if nx number of electrons travel a differential distance dx, the number of electrons will be dnx. So dnx is equal to alpha nx dx. So this is differential increase in number of electrons, that is equal to alpha nx dx. So this is initial condition at x is equal to 0, nx is equal to n naught. Okay, so keep this condition aside. Afterwards we will use this condition. Okay, again we will take this equation, the same equation I have written it here. Okay, dnx is equal to alpha nx dx. So here we'll bring this nx this side, we'll bring this nx this side. So we'll bring this nx to the LHS side. So dnx by nx is equal to alpha dx. Okay, dnx by nx is equal to alpha dx. Okay, so I have brought this nx to the LHS side, so it becomes dnx by nx is equal to alpha dx. So at this point I'll integrate. So integrating on both sides, I'll apply integration on both sides. So integration of dnx by nx will become natural logarithm. Ln is the natural logarithm. Ln nx, that is equal to alpha x plus c. So that is equation 1. So ln natural logarithm of nx is equal to alpha x plus c. So c is a constant here. So c is a constant. So you have to find out the constant c value by using initial conditions. As like transients, we will find out c value using initial conditions. So substituting initial conditions to find out c value. So what are the initial conditions? At x is equal to 0 and x is equal to 0. So sorry, at x is equal to 0 and x is equal to n naught. Those are the initial conditions. So I'll post this slide. You just try to understand. Okay, this is the next slide. So substituting the initial conditions. Okay, substituting the initial conditions to find c value. So substituting the initial conditions to find c value. So that means at x is equal to 0, nx is equal to n naught. So in this equation, if you see here, ln nx is equal to alpha x plus c. That is the equation we have got. In that equation, we are substituting the initial conditions. So x is equal to 0, nx is equal to n naught. So substitute that condition here. So ln n naught is equal to alpha plus c. Ln n naught is equal to alpha into 0 plus c. So this term will be 0. So you will get c value. C is equal to ln n naught. Okay. So what are your initial conditions? At x is equal to 0, n is equal to n naught, nx is equal to n naught. So we have substituted this. Take it as equation number 2. So substitute equation 2 in 1. That is remove the constant. So ln nx is equal to alpha x plus ln n naught. So this is C value. So bring this ln n naught this side. Bring this ln n naught to the LHS side. So ln nx is equal to ln nx minus ln n naught is equal to alpha x. Ln is a natural logarithm. Okay. So log of a minus b is what? Log a minus log b is log of a by b, right? So similarly here, ln of nx minus ln of n naught can be written as ln of nx by n naught. That is log a minus log b kind of thing is equal to alpha x. Okay, moving on to next page. So in the previous page, this is the equation we have got. So if we bring ln to the RHS side, what happens? Bring the natural logarithm to the RHS side. So it becomes e power alpha x. Nx by n naught is equal to e power alpha x. That is what we get if the natural logarithm is brought to RHS side. So that is nx by n naught is equal to e power alpha x. Nx by n naught is equal to e power alpha x. That is natural logarithm here is brought to RHS side. So nx is equal to, bring this n naught to the RHS side. Nx is equal to n naught into e power alpha x. That's what we get. So actually we want the number of electrons at whatever the distance we desire. Okay, so this is the equation we got. So the number of electrons reaching the anode at distance x will be. So if the number, what is the number of electrons at a distance x is equal to d, or the number of electrons reaching the anode, that is positive plate, at a distance x is equal to d will be. So for this substitute x is equal to d, you will get nd is equal to n naught into e power alpha d. So this is the number of electrons at anode. So this is the number of electrons at anode. So this is the number of electrons at anode. Okay, nd is equal to n naught into e power alpha d. So this is the desired equation. Okay, so further you can do some small understandings. Some small inferences can be gotten here. So nd is equal to n naught into e power alpha d is the required equation. See further, see if you see here, number of new electrons created on the average by each electron. Okay, on an average each electron will create how many electrons? If that is the point, then what? So here, number of new electrons created by on the average by each electron. For suppose, so you know electrons are moving from cathode to anode. So in between the journey, how many number of new electrons are created? That is a question mark. So each electron will create how many new number of electrons? So if that is the question, the answer is this: nd minus n naught by n naught. So nd minus n naught by n naught will give average number of new electrons created by each electron. So each electron will undergo a lot of collisions. So number of electrons created by each electron is nd minus n naught by n naught. So nd is the number of electrons at the anode minus initial number of electrons by n naught will give number of new electrons created by each electron. That is the thing. Okay, number of new electrons created by on an average by each electron is nd minus n naught by n naught. So leave this thing, you can leave this LHS side apart. So our RHS side is important. So from this equation only we have got this. For suppose you can take here nd by n naught, you can bring n naught to LHS side, nd by n naught, e power alpha d will be there. So on LHS side and RHS side you place -1, you keep -1, so you will get, if you take the LCM, it will be nd minus n naught by n naught. That's what we will get here. So we have got this equation from this only. So from this equation you do nd by n naught, bring this n naught this side, add -1 on both sides, and you take LCM, you will get this equation. Okay, so if the question is how many new electrons are created by each electron, your answer is this, nd by n naught by n naught. Okay, so proceeding to next point. The average current in the gap which is equal to, so you can convert this equation. So our final equation is this, nd is equal to n naught into e power alpha d. So our final equation is this, nd is equal to n naught into e power alpha d. This is our final required equation. Okay, this is our final required equation, nd is equal to n naught into e power alpha d. Okay, so this is nothing but nd is equal to n naught into e power alpha d. This is our required equation in terms of number of electrons. So if I want in terms of current, so current is nothing but flow of electrons. So in place of n I can place I. So that becomes a current equation. So in place of n, if I place I, that becomes id is equal to I naught into e power alpha d. Okay, that's what we get. id is equal to I naught into e power alpha d. If you so in place of n you place I, that becomes a current equation. So this is your again final equation in terms of current. So what is that? I is equal to I naught into e power alpha d. So this is the current because of the collisions. That is the current because of collisions. So those two equations are important. Okay, so what are they? nd is equal to n naught into e power alpha d and I is equal to I naught into e power alpha d. Those two are important equations. So where I naught is the initial current. So where I naught is the initial current at cathode. So where I naught is the initial current at the cathode. So this is the equation we require. I is equal to I naught into e power alpha d. That is the equation we require. I is equal to I naught into e power alpha d. This is the final equation that is required. Or nd is equal to n naught into e power alpha d. That is in terms of number of electrons. I is equal to I naught into e power alpha d. That is in terms of current. So that is as per Townsend's equation. That is Townsend's equation. So here we have considered ionization only because of collisions. Okay, so we have considered here ionization because of only collisions. So here electrons are assumed to emit only because of collisions, that is ionizing collisions. But actually we have got secondary collisions as well. So what are the secondary collisions we have got? So collisions because of positive ions, electron emission due to electrons, and electron emission due to metastable atoms. So these are the three more that are there. So because of that also electrons will be liberated. So have you understood this derivation? Any doubts in this?